Welcome to the project demonstration of battery management system along with fire protection. The main application of this project is when we are utilizing the battery packs in electrical vehicles due to the overheating or overcurrents while charging the battery pack or while connecting the load to that. So the overheating method chances are like over voltage providing to the battery pack when we are charging the batteries, or else heavy load occurred on the battery pack when we are connecting the load to that. So here we are using this 1000 rpm DC motor as EV vehicle, so electrical vehicle load system, and the charging circuit will be done through this relays, and continuously we need to monitor the voltage and current of this battery pack along with the temperature. So while charging the battery pack, we need to get the voltage to cut off the battery pack voltage, and we should inform the low battery voltage also. While monitoring the currents, we should know the temperature of the battery pack. If heavy load was occurred on the battery pack, then the battery temperature may increase. So in order to protect the battery pack, we need to place this temperature sensor near that, and we can prevent the fire accidents also. And also when the temperature increased, we'll get the alerts through the buzzer, as well as the system will on this cooling fan to cool down the temperature of the battery pack. So overall, the main features of this project is we can charge a battery pack whenever the battery or low voltage occurred with help of these two switches, that is fast charging and normal charging, and that will activate these two electromagnetic relays, and the voltage of this battery pack measured by this voltage sensor continuously, and the current of this load consumed by this load will be measured with help of this current sensor. So totally voltage sensor, current sensor, and these two are the switches to isolate the power to the voltage sensor. Just we need to make the fault, as we are using the full charge battery packs, so we need to make the battery low voltage fault. So just we need to isolate this battery pack to the microcontroller as informing of 0 volts. Then the system will inform us alerts through this buzzer, and the same to on and off this load also. Okay, these two switches for voltage and currents, two voltage sensor and current sensor, and this the transistor board to on and off the fan whenever the voltage increased to the threshold value around 43 degrees above, then automatically the fan will get switched on. And these two relays to on normal charging and fast charging. This is a charging circuit which will take 12 volts of AC inputs from the transformer, so which will take 12 volts AC inputs and provide the 12 volts of AC, and the output of this charging circuit is input to the battery pack through this relays, and it has the 3 stages: rectifier, filter, and regulation. After regulation, we will get 5 volts DC output. So the 5 volt DC output is input to the microcontroller, as the operating voltage of our microcontroller is 5 volts, and this is a buzzer board and the selection switch and LCD board to show the status of the total sensors data. And here one more feature is SOC and SOH. SOC nothing but state of charging, means when we connect the charging circuit to the battery pack, it has to measure the percentage of voltage increasing with respect to the time. So for example, as we know that if we connect the powerful adapter to our mobile phone, so in 1 minute around 1.5% or 2% will be increased. So otherwise it's not increasing, nothing but the state of charging is very less than the normal one. So same thing happened here. So when the battery voltage is increasing certain levels respective to the time, then the percentage of the SOC will be reaches to the 90 to 100%. If it is not charging properly respective to the time, then the percentage of SOC will be decreased from 90, 80, 70 like that. Same SOH also, the state of health. So when we are charging the battery, we will get SOC. When we are connecting the load, then we will get the SOH. So if the battery voltage is drastically decreases when we connect the load, then it will affect the SOH values, means it won't show the 100%, 90% like that. So if it is normally discharging based on the load, then the SOH is going to be the nearby 100%. So that is the calculation of this main project. So let us see the demonstration. Just on the power supply to the kit, and a welcome message displayed on the LCD screen, and then after continuously measuring of voltage and current values, we can see on that voltage 13.0 volts, current is we are not on the load, that's why 0 milliamps, and SOC SOH calculation will be done after 10 seconds of duration, and temperature is 29 degrees centigrade. Everything is normal here. Now let us make a fault of, let us add the load here. You can see now this 1200 milliamps, nothing but 1.2 amps of current consumed by this load we are using here. You can see the SOH is 92%, SOC as the 100% we can see here. And the next, voltage isolation. Just we have disabled the voltage sensor voltage. Right, so you can see the low voltage is beeping us as alert. Now just select the switch, so which will on the charger. Okay, and when we select these switches, automatically two relays get switched on. So nothing but two relays in faster charging it will be done. So it will take around 1 to 2 hours to be get fully charged. After once the battery reaches the threshold value, means above 11 volts, then automatically the relay will switch off. When it is below 8 volts, then it will get the buzzer. Okay, and coming to the temperature. So when it crosses the threshold value of 43 degrees centigrade, then the system will provide us audible alerts along with fan will get switched on. Right, 45 degrees we set the limit as the fan will switch it on and will provide the buzzer alerts to this.